Inequations. Instead of an equal sign, we'll see greater than, less than, greater than and less than, or less than or equal to. And you're asked to solve this. And you might say, I don't really have a clue, so let's relate it to something that we do understand. If we were to let y equal x minus 3, x plus 1, x plus 2, we could think about graphing it. We know the x-intercepts, we know the y-intercept, and we know what the graph looks like. Now, let's take a long look at this graph. We're looking at the y values. These are all the positive y values up here, and these are all the negative y values. So the negative y values, negative 1, negative 2, negative 3, negative 4, negative 5, and then the positive y values are the ones up here. So what we've done is we've really split our graph into 3 sections. Anywhere that your y values are positive, these sections, we've got y greater than 0. Anywhere that y is negative, there's y less than 0. And on the x-axis, that's where y equals 0. All right, what were we trying to solve with this? We wanted y, which is equal to this, to be greater than 0. So the blue region is showing us where y is greater than 0. So we just need to describe the blue region. It starts at negative 2 and ends at negative 1. It starts at 3 and goes to infinity. So when you describe your region, you're saying, where does it start? What's the point on the left? Where does it end? That's the point on the right. So this is known as interval notation. We use round brackets to say you cannot actually equal negative 2. There's no equal sign up here whatsoever. And so what we've done is described where this expression will be positive. So the blue region is actually our solution. And you might look at it and say, okay, hold on, I'm a little bit confused. We talked about y, we're trying to solve for x. What is going on here? And it's simply because we let y equal the equation. So because y equals the equation, as long as y is positive, this entire expression is positive because they're the same thing. Test your answer if you want. We're saying we should be positive from 3 to infinity. So let's pick a point. Let's put in 4 and see if this works. When you multiply 4 minus 3 times 4 plus 1 times 4 plus 2, are you greater than 0? Yep. That seemed too easy. If you want to check a point that should not work, we're saying 0 is not part of the answer. Try plugging in 0 and seeing what you get. When you plug in 0, you get minus 3 times 1 times 2, which is negative, not part of the answer. So it looks like this works. So again, what do we do with this? Sorry, I've already given you the x and y intercepts. We need to start by letting this equal to y. And anytime you learn something new in math, it's always good to relate it to something you already understand. If we want to graph this, let's check our factoring methods. I think these are in the same ratio. That means we should be able to factor that using a common factor. If I pull x squared out of there, it's multiplied by x minus 3. Pull out minus 16, it's also multiplied by x minus 3. That's good, because then we have a common factor of x minus 3. We'll put that out front. It's multiplied by x squared minus 16. Two terms, minus sign, both squares. That's the difference of squares. And that's where those x-intercepts and y-intercepts came from. Draw the graph. Separate it into 3 different regions. Anything above the x-axis is where y is greater than 0. Anything below the x-axis is where y is less than 0. What do we want in this case? Less than or equal to 0. So the solution is going to be the black and the red section. So we have to describe this section and this one. And remember, your goal is to describe this going from left to right. So if you look at the very left-hand point of that, where is it? Looks like it goes on forever. So that one would start at minus infinity. The right-hand point is ending at 4, And then you have to ask yourself, am I allowed to equal these things? I'm allowed to equal 0, so yes, I'm allowed to equal 4. So we indicate that with a square bracket. Can you ever reach infinity? Never. So that's a round bracket. So there's that answer. This one, left to right, starts at 3, ends at 4. Are we allowed to equal 3 and 4? Yes, because we're allowed to equal 0. So that answer will describe the regions where this expression is going to be less than or equal to 0. If you would like to test it, -5 should work. So if you plug in -5, make sure you're negative. Or an easier one to test, I like to test it with 0. 0 is not part of the red region, which means when we plug in 0, it should not satisfy this. Plug in 0, we get 48. 48 is not less than or equal to 0, which is good, because we said it was not part of the solution. Okay, your job today, you're going to do some more graphing, which you're very, very good at. What you just need to work on today is picking out 3 regions. Anything above the y-axis is where y is greater than 0. Anything below, that's where y is less than 0. Anything on the axis is where y equals 0. And then take a long look at what region we're looking for. This one, because we wanted less than or equal to 0, we wanted less than or equal to 0. And that's why we picked the black and the blue region for this one. All right, enjoy these.